Yes. Okay. Thanks, folks, for joining. We are back again after a month of exciting work and updates. So I just wanted to go through a few things that have been going on. Of course, our standing meetings. Geppetto has been having meetings, which Matteo will update on. Movement Validations had a meeting, which I'm sure Michael will be able to update on. Muscle Neuron had a meeting. I'll talk a little bit about that towards the end, so that I don't take up all of the air in the room. And then OpenWorm, although it has not been meeting, had in the earlier part of this month quite a lot of activities. Trailed off a little bit because things. So some of the other bits of the project have sort of taken some additional attention, but has been getting increasingly closer to release, which is good. So that is also continuing on, and I can say a little bit more about that as well towards the end. In terms of big picture, so you guys will remember that we've had a few different things to integrate in terms of looking at the big picture, and one of them was goals. So what I have done here, which is linked into the agenda, and I think you can also click through to it. If you don't have permission, let me know. I think I should have put it out. So I've taken the points. You'll remember in London we sat around and we wrote stuff up on a board. And so I have literally just transcribed what was on the board. And the only other thing I've tried to do is I've sort of tried to group those things into categories that I think I got right, but could be wrong. But basically, I've tried to put them under sort of headers. So these were the things that were generated by you guys back in November for what goals you wanted to have in the next 6 months. And so they're in these various areas, of course, by OpenWorm. Some things are sort of sticking out, like LEMS implementation for FPGAs, although that's cool. A lot of things under Geppetto, which I think are actually kind of coming along quite nicely already. Feedback from Cybernetic into JLEMS should probably be actually. Well, I don't. That one's like a cybernetic or C302 topic, so it kind of fits in the middle between the two. Maybe actually just put them between the two. C302 goals are there as a reminder. Cybernetic goals are here. Deliver worm sim to backers. There's a lot of things that I've put under the broader scope of movement validation, which also includes data. And then there's cybernetic stuff that are down at the bottom. Looks like I've actually got 2 of those sections. Right, so these are the different pieces and parts that we put together, sort of big picture goals. Now, all read separately, they obviously have trouble kind of gelling in the mind of what this all adds up to in a bigger picture. So I've been working to try and get some bigger pictures together. In the past, Michael and I have gotten together and just tried to sort of cast the project as a whole. And you've seen some of the results of that in terms of the Prezi that I put together in the past. So, I constantly try to, come up with ways to visualize this. Recently, Matteo actually sat down and started thinking about this in terms of a block diagram. And so this is actually very new, but just as a way of kind of getting a tour or a big picture idea of what's happening in the project. And I know this is intended to clarify, but probably already sort of looks like it's kind of complicated. But there's actually some good pieces in here that I think fit together, and maybe we can have Matteo walk through it since he's the author of this in his section. But the goal is for us to all kind of, in addition to having our sense of what's happening in our local pieces of the project, to have an idea of the big picture. And let me just sort of state, without walking through this diagram, just like state what the big picture is that if we work backwards from a scientific publication that basically says we've done the things that our perspective article said we were going to do, which is that we've built a neuromechanical model of the worm, we've taken videos of, extracted videos from a data set, we've pulled statistics and features out of both our model and of our features, both our model and features from real data, and we've compared them together, and they match very highly, right? That is, in a nutshell, I think the goal that we're shooting for. And all of the other things derive from making that happen. Infrastructure for seeing the pieces and parts that we can make happen, infrastructure for building the models of the muscles and the neurons, infrastructure for processing the videos, infrastructure for seeing all this on the web, and then of course there's also our community goals, which are, take up time, working with contributors, community goals, like making things more available to people that are out there, and all those are fine. But it is one where we can interrelate these together and be able to see where dependencies lie and see what some of the critical paths are towards making this fit together. And so this is still in progress, but I think that, and obviously we can't command these timelines to happen based on open source stuff, but I think this is really the critical meeting for integration, and it's really those of us in here having the mind share of what the big picture is that helps to roll out to all the other folks that are sort of contributing and helping with the project. So the more that we put that together, the better. One thing that I'm going to instigate in this next month is, and Michael just left because he was kind of the relevant person. One of the things I'm going to instigate is a meeting between like Michael and Jim and Matteo, which I think is overdue, but we will get that put together and as a sync point for this next meeting. So let me continue to work on this and sort of be able to present this in a more formal way in the next go round. But I just want to give you a sense that in fact we are doing work to integrate this at the top level and put these pieces together. Okay, questions on that much so far? All right. So just a couple other things, big updates at the organizational level. So Google Summer of Code is coming. Mentor organizations just submitted applications. As a reminder, we are not a mentor organization officially as far as Google is concerned. We are under the umbrella of INCF, who graciously agreed to continue to sponsor us under their umbrella. So we're assuming that they are going to again be picked as a mentor organization if that hasn't already happened. So we put out 2 ideas on their ideas list, which is sort of a they're aggregating across many different projects. And one of them Matteo put together under Geppetto, and one of them I put together sort of combining with Porig. A modeling project idea. Now, what happens in the next couple months is that students will make proposals to INCF to do work, and then by the time hopefully they get picked, and then summer will start, and they'll be working in a more extended period of effort over the summer. Which requires some supervision. Now, this is not a closed list. This is just the first ideas that we've put out. So there is still the opportunity for folks to put more things on here, and I've sort of solicited some of that from the group. We can put more up. The trick is, if you put an idea in, you're going to have to be prepared to actually mentor a student. So that's the one catch, is that we actually have to do that, and it is time consuming. And last year I found out how time consuming it was. So, but it's good. So we got things going forward. So I would urge folks, if you want to be involved in this program through this, and you want to either try to have a whole idea that you want to do yourself, or if you want to be party to any of the other pieces that are up there, just let me know. And for folks that are watching, anybody is invited who is a student to apply for the program, and we hope that you will. We actually already have one person who's expressed interest in the modeling project, who's been working in the muscle neuron team, who is a student and who would love to do an internship this way. So, so we've already got one identified. That's moving forward. Who is that? Wilson Zhao.
Sorry?
Wilson Zhao.
Okay, probably yeah, feel better that.
Yeah, he's going to be an incoming Carnegie Mellon computer science freshman, and he's been very quick at being able to build everything that we've put up on GitHub. So, so it'll be good. Okay, and what else? What else is going on? Let me go back. Okay, the Gitter channel is still going on. I think it's had slightly less traffic in the last couple of weeks, but first few weeks were strong. Don't forget that it's a really good way, really good way to interact with folks on there. Okay, and that gets on to the structure of this meeting. So we did say that we were going to continue to have focal points on different topics, and Porig volunteered this time to speak in some more depth about things that are under his wheelhouse. And that means that we will need to have another volunteer for next time. Can we get that volunteer now who would be willing to spend about 10-15 minutes going a little bit more in depth in their section of the project? Anybody?
We can do Worm Sim next time.
Woo! Worm Sim. All right. Thank you for the volunteering. Sounds good. So then let me turn it over to Porig for his update, and then we'll do a round of updates after that. Yes.
Okay. Okay. I very much want to share my screen, but the button at the side is not happening. So I may have to get Stephen. Could you possibly share your screen and go to the C302 folder in GitHub? Could alternate. You're mute.
I was saying yes, I can do that, and I was starting to do that, and then
Okay,
I was
sorry.
window. So it's my apologies. Okay, so you want me to go to the C302 folder where?
In GitHub.
Yes.
It should be in celegans/pi. Well, I should just send you.
Nope, I'm getting it. Yeah.
I can actually, if anybody else wants to, look at it there. Okay, great. Yes. Python script C302. And there's, in the README, there's now an image.
Ooh, look at that.
Okay. Well, the basic idea here is that C302 is really a Python framework for generating multiple different NeuralML files from sets of parameters and small sets of data that you actually put in to specify which cells you want, what the parameters of cells are, and the level of detail of the individual cells. So on the left, there's a varying, so these parameters that I spoke about before, parameters A, parameters B, parameters C, parameters D, are different levels of detail in the individual neurons, and also to a certain extent different properties of synaptic connections. So A starts off with just simple integrated fire cells, B has integrated fire cells with gap junctions and with this kind of measure of activity in the neurons, so a kind of a smooth value between 0 and 1, which reflects how basically the level of firing activity in the neuron. So closer to 1 means the cell's more active. Level C is point neurons, but they have ion channels in each of the individual cells. So for these, at the moment, they're just based on the muscle model, which has fast and slow potassium channels and calcium channels. So at the moment, if you generate a network of 302 cells with these, they'll actually be muscle models, which is not correct, but it's a first start on something to use for a more accurate conductance-based neuron model. And at the top there's level D, which actually uses the multi-compartmental cell models, and which will use so the realistic morphologies, and will put ion channels on these and internal calcium, and in theory can generate the entire in any given area region of a cell, can give you the membrane potential and calcium concentration and so on. So level parameters at D isn't worked on yet, but A, B, C are present in the GitHub repository. The idea here as well is that not everybody will want to analyze the entire network. You might just want, for example, that social network, which consists of about 7 cells known to be involved in social behavior. You might want a subsystem like the pharynx, or you might just say, give me the whole of the cells, all of the muscles. So in individual Python scripts, you specify which sets of neurons you want, specify the list of 7 cells for the small network or social network model, and then set a different parameter for the biophysical detail, and you can analyze these as integrated fire neurons or multi-compartmental neurons. And at each stage, it will use the data from the connectome on which cells are connected to which cells. You have an independent set of maybe about 20 different parameters for the properties of the individual neurons, the properties of the synapses, the relative strengths of excitatory inhibitory connections and gap junctions, and all of these can be set in the same kind of interface, no matter whether it's multi-compartmental cells or integrated fire neurons. So in this way, if you build, for example, an optimization framework for generating a network, optimizing against 20 parameters, you can use the same framework for optimizing the 40 or 100 parameters for the multi-compartmental models, independent of that. And you can ask for the membrane potential, run the simulations in Neuron and in JNeurML in the same way. So, okay, so from that point of view, for each of these along the top, along the axis going back, you have the Python scripts. So each of these Python scripts will automatically write NeurML files for you for running these simulations, and also for example, for giving this to Geppetto for visualizing in 3D, but it can also be used to generate neuron code. So the idea is, again, to try to keep this as standards compliant as possible, as easy to get into Neuron as possible, and then in theory, if another simulator comes along that supports this, it just needs to have the mapping from Neuron to that simulator and can be used in this framework as well. So that's the overall scope of this. As I say, each of these sets of parameters, and I'll just send another link here. If you can follow that link, Stephen, in the chat.
Yep. 1 sec. Move it over.
Okay, we go down. Keep going. Yeah, there. So basically, this is where the parameters. Oh, sorry, up a little bit.
Oh. Here.
Yeah. So those add bioparameters. So those, for example, chemical excitatory synapse GBase. Those are for the parameters used in the NeurML models. So each of these, it just basically extracts out any physiological parameter and allows you to set them in the same way. If you look at the bottom of the page there, what it's doing in this instance here, so this is parameters A, it's creating an IAF cell down at the bottom of the page using these parameters. Now that integrated fire cell is kind of hard-coded as being the cell to use in parameters A, so in a sense that's hard-coded, but if you've chosen a level of description for integrated fire cells or for point neurons with conductance-based, you just get a set of these bioparameters, so 20 or maybe say 40, that can be set for that level of detail, for that configuration of the network, and then ideally you can tune your network to produce whatever behavior you want from that, depending on those set at that configuration. But you can tune the parameters you use for the cells and synapses and so on to ideally produce the behavior you're looking for. So if you wanted to produce an oscillation, if you wanted to produce some kind of response in a certain set of neurons given some particular input, then this framework will allow you to pick your level of detail and tune the parameters. Now, the next main step with this, apart from enabling this for multi-compartmental neurons, is to hook this up to Mike Fella's NeuroTune, whereby, and so he has a framework where you set your parameters. It has a framework for optimizing the model, running a model a number of times. You set a range of values for example, these parameters. Some tests on the output of the neurons in the model, and it will run a genetic algorithm and various other methods for optimizing according to your chosen output. At the moment, that is more focused on electrophysiological data. The problem I just ran into now is that it's a little bit hard-coded for assuming that there's a strong peak in the action potentials, and so it makes it a little bit difficult to analyze the types of traces that we're getting out of the invertebrate neurons, but it is extensible. It can be modified to look for different behaviors, and so that's the next step, really, just hooking up this generic framework for specifying these parameters to that framework, and then you just specify your target behavior. You say how your values for the synaptic properties and so on can vary, and hopefully it'll run a number of simulations using either JNeuroML or Neuron and optimize the model. And what comes out at the end of it is a set of these parameters which can be automatically converted into a neuron model for running in Neuron or for analyzing or visualizing or anything else. Excuse me. So that's the overall framework. Again, there's lots of bits to do, but it is slowly getting there. And the next main step is hooking it up to NeuroTune, Mike's package, and trying some of the models that come out of this by hooking them up to cybernetic. So that's a quick introduction.
Cool. With that NeuroTune stuff, is anything particularly new? That is the part that's probably needs the most help in that vision that you've completed. Is that right, or?
Well, I mean, I've just gotten back into it. What I really had to do was make it easy to run these models through Python, because ideally that's a Python-based package. So that's the work I had been doing on PyNeuroML for the last while, which is it basically wraps JNeuroML in a Python interface. So if you want to run, if you want to generate some neuron code and run that, you can do that with JNeuroML, and now that functionality is wrapped in PyNeuroML. So you just say, okay, run this model with Neuron, and it will do all the conversions in the background using the Java jar. So I just got that working in the last week or two, and I've just gone back to NeuroTune, and just today I saw that, okay, some of the parameters in there will have to be tuned to make sure that, for example, running or analyzing an integrate and fire cell, which just goes from -70 to -50, which was what C302 was just guessing at the moment. Some of those parameters will have to be changed, but in theory, it can be updated with all of this. It's just looking through the package, adding some tests to NeuroTune, and running it on that, and then maybe trying to find some kind of behavior that would be useful to optimize against. Okay. The other main issue is going to be that it is built around analyzing and optimizing for single cell models. So you just have one single trace that comes out, and you want to, for example, putting a current into a cell, and you have an experimental value, and you want to optimize your model for that. It's not really set up for networks yet, but that's something that can hopefully be added.
Okay. Do other folks have questions?
Intersections between these It's coming along very nicely, Porrig. Whether the intersections are either existing or planned, if any, with PyOpenWorm?
Yeah, I mean, at the moment, all of the information from okay, which cell is connected, ADAL, which cells are this connected to, they are just being taken from the spreadsheets that we use for the NeuroConstruct project as well. So as soon as Stephen can say that yes, all that information from those spreadsheets. So I mean, if you read any paper talking about C. elegans connectome, they'll all be pointing to Wormbase, and the majority of them will be pointing to 2 or 3 spreadsheets that have been downloaded from there that have been published in the last few years. As long as all that information is in PyOpenWorm, then it's fairly trivial to pull that, instead of pulling the information from the spreadsheet on which cells are connected to which, we pull it from PyOpenWorm, and then hopefully that metadata on, okay, where this information came from can also actually be built into this, so that when you actually generate a NeurML file, maybe it's hard-coded with some comments to say, okay, this connectivity data came from this version of PyOpenWorm using this spreadsheet at this date. Yeah. But for the time being, I mean, I think they're fairly close anyway, whatever will end up PyOpenWorm in this. And I mean, the framework itself can definitely be built on top of connectivity data using from the spreadsheet.
Yeah, there is actually a pull, an old pull request that's probably going to have to be modified, but the Google Summer Code student went so far as to write code that actually causes C302 to be generated from PyOpenWorm rather than from the spreadsheets, and so we've been a long way around, but that is one of the fragments that we would like to pull the trigger on, and I'll give you more of an update on where that is later.
Yeah, I mean, that's probably just using the kind of bare minimum of facts that a cell is connected with this N connections. But I mean, there's more, hopefully, that can be pulled from PyOpenWorm on the evidence associated with that fact. So it would be good to get that in as well. And here as well, I mean, as you can see on the screen, in theory, associated with each of these bioparameters for electrical or chemical inhibitory synapse, at the moment I have written down just blind guess. In theory, that string, I mean, it can be modified to a certain extent. Each of these parameters should have associated with a string for where it actually has come from. I mean, you could replace this with a result of running an optimization algorithm on movement behavior, or a reference to a paper here if somebody knew that, okay, some property of synapse was actually recorded in the paper. So ideally, all this information gets into the NeurML file. So if somebody just finds that NeurML file, they'll have lots of metadata in there about where all these parameters came from.
And, ideally, the best way to run this is through
At the moment, JLMs. There should be instructions on the README for how to get JLMs and how to install. I mean, to run the Python script against to regenerate some of the NeurML that's there. You'll need some other Python packages like airspeed for converting templates. However, to actually run the generated NeurML code, all you need is JNeurML, and there are some examples in the C302 folder as well of pure LEMS files, and any of those should be easily readable by JNeurML. PyNeurML itself is still in flux. I mean, it does work. You can use PyNeurML at the command line instead of typing JNML, type PyNML, and that will run these models as well. I want to make it as easy as possible to run them, and I'm hoping that instead of this long list of dependencies that are associated with this, for getting these running, you just install PyNeurML, and then that package will allow you to run. It'll install all the Python dependencies in the background and make sure everything is there for you to generate and run, and hopefully run many simulations using this framework.
Cool. Other questions for Porrig?
Would it be conceivable for it to have something like a Travis job that is executed every time you change something to C302 that will automatically regenerate the models?
I think it is running some of the tests. Some of the tests do run C302 models. I'm not sure if it regenerates everything.
Because from my perspective, what I'm thinking is that it would be nice to have a go-to folder where there is the latest of each one of these models that you have in that matrix, like A, B, C, D, different complexity and stuff like that. Because
I mean, there are certainly examples in there in that C302 folder of parameters A, social network, and that checking that out, cloning that repository will give you everything you need for running parameters A with the social network. I didn't want to commit all of them because it would be 20 or 30 different extra files there, and some of them would be quite large.
Maybe they could be either in a separate repository that because I see C302 as the set of algorithms that are generating these models, and I know that I've been playing with them because I was loading them in Geppetto, and I know that there are a few of them here and there, but every time I just from my perspective, I'm never sure, or is this the latest? Was this regenerated with the latest, etc., etc. I was thinking that it would be nice to have because it's like 30 models. It's I mean it's a very manageable amount of stuff.
True, but they're 30 random points in a hugely dimensional space. I mean, one thing I don't want to do is kind of suggest that, okay, this is the latest version of the multi-departmental model with these parameters. Most of those parameters, of those 20 parameters, are, as I said, blind guesses, and they don't actually do very much. When
I know.
So, I mean, this is similar to with the problem with the neuroconstruct project. That a lot of people looked at that and said, okay, well, that's the worm I want to download, and what is a neuron? I don't want to kind of highlight or suggest that this is the current version of the neural network, and here are the currently best parameters, and somebody looks at those and thinks, okay, well, those are useful, or they're a useful first approximation. I mean, all they should be considered as are just some examples of NeuralML, which should run with Geppetto or should run with Neuron, rather than this is the best worm we have at the moment.
Oh yeah, I mean.
So I know you understand that, but I mean that's 2 seconds, and why I don't want to put them out there and point at them and say, well, look at this set of models. Use these if you want to look at the current worm.
Yeah, because from my perspective, I'm just coming from the angle of we know that all of these models they're a work in progress. They start from wild guesses, etc., etc. But at the same time, it will. I think that the likelihood of their improvement over time, it will depend also on how much we expose them in a way. So that's why I was thinking, for instance, what would be nice would be to have like, and we can put like a label that says how good it is. I actually what I was thinking is like this could be, for instance, a repo linked from Open Source Brain, and Open Source Brain has the star system and all of that to say how good the model is and so far and so on. So that we get to the point that they could be easily opened, and looked at and simulated. So maybe that's something.
Yeah, I mean, isn't this the case with the OSB project on the C. elegans project on OSB at the moment? That I mean, because these are in, I think it is the case. Networks generals. Yes. Okay. Yes. So I mean, if you do go to the OpenWorm C. elegans network model on Open Source Brain at the moment, you get in the OSB 3D Explorer C. elegans Python script C302 underscore A underscore social. So I mean, you do see these under there now. There's about 10 of these. So there's 10 examples of NML files with showing C302 examples. So yeah, and can potentially be visualized as well. So yeah, I mean, maybe I do need to put a few more, but I mean, if I put every one of them up there, it's probably going to be 20 or 30 different files. And I mean, I need to restructure it anyway. I need to put probably C3 or 2 in its own repository and make sure that it's accessible in that way. But yeah.
Okay. Cool.
All right, excellent. Any more questions? All right. We'll probably move on. Oh, Tom? I see you're trying to speak, but I think, and I see that you're unmuted, but nonetheless, the audio is not hearing you. Okay, he's going to try to figure it out. Microphone settings. Maybe while you're doing that, we'll sneak in an update from somebody else. Okay. Let's see. Who do we have next? So anyway, so thank you very much for walking us through that. Once Tom gets on, he'll ask your question. But seems like a lot of good stuff going on there, and lots of good intersection points for us as we move forward as well. And yeah, the neuro optimizer stuff. Lots of folks have been asking about that too, so that'll be cool. All right. In terms of who's next, let's see. Next on the list, we've got Michael. Can you give update next? Okay.
Sounds good.
Sweet. Thank you.
So yeah, so we've had a couple of meetings since last I spoke to the general group here. We had a standing meeting on the 15th of February, and one thing that's heartening about those is that there's been very consistent attendance from some of the new guys. So that's excellent. We got Chris Lindsay, Joe Bowen, and Randy Nguyen. And Joe's been working on the cloud work. Randy's been working on getting Sphinx working with our documentation. And Chris Lindsay is planning on working on some demonstrations with the IPython notebook of feature calculation methods. So working on that stuff. Of course, Jim's there also. Steven's been a regular attendee also, so thank you. And we also had a meeting with the Brown Lab on the 16th of February about the computer vision problem. So that was, I think, quite a productive meeting. And basically the next action out of that meeting was Steven's meeting with one of their PhD candidates, Kezi Lee, to set up a GitHub repo where some of his work that he's been doing will be continued. And I think that's really good because then there'll be visibility and hopefully we can contribute to it. And I think that's a good development there. It underlines the Brown Lab's commitment to open source and developing this in an open way. So that's fantastic. Recently, ahead of the standing meeting, I grouped all of the outstanding issues. Oh, it looks like Steven's linking to the new repo. So
that's
awesome.
the Brown Labs organization. There's not a lot in it yet, but that was the output of that session. So.
Do we have the so we have the organization? Do we have the repo yet, or I guess
we put a repo under it.
Cool.
And like they still need to be. This still needs a little bit of work, like readmes and all that good stuff. But mainly we were just making sure they had the mechanisms to put stuff up. So
awesome. Right. So as I was saying, we've grouped all of the GitHub issues into 4 milestones. So if we completed these 4 milestones, that would complete the project. So I think that's a logical way to organize it. So we have the feature, statistics, fitness function milestone, computer vision milestone, the cloud milestone, and the testing/documentation milestone. So my focus right now is on the feature, statistics, fitness function, specifically getting it into a minimal state where we have the loop closed with Geppetto, and we'd call that our minimum viable product to be able to at least deliver some fitness function to Geppetto. And so that's my personal focus, and I'm working on that. One part of that is developing, as we've spoken about before, a specification for what a worm wireframe would look like and what that in a minimal state would be. And so working on that is my focus. And that's basically the state of the movement validation team.
Awesome. Thank you for linking to these things, and these are the things that are the rows in the Gantt chart as well for showing these pieces. I'm going to keep going on progress, but in the chat, Michael and Matteo, I'm going to be searching for a mutual hour that we can agree, the three of us, to meet and chat in the next couple weeks or so.
Sounds good.
We'll take that there. Okay, great. Oh, except Matteo's the next presenter, so we'll do that after Matteo finishes presenting. Okay, so thank you. Now on to the Geppetto update.
Okay.
Oh wait, and did we get, Tom, did you ever get your audio? Sorry, testing. No, still microphone not working. Okay, well you can type your question in the chat and we can address it then. So all right, go ahead, Matteo.
Okay, so couple of things. I will give an update on the Geppetto project. Then, if we have the time, I would spend 5 minutes walking through that diagram that you presented at the beginning, as I think it would be useful to sort of, at least it was useful for me to draw it, to paint a picture of the different intersection points. But I will go first into the Geppetto update. Okay, so this is the agenda. I was also sharing it, but just for me to read the stuff. There are the meeting minutes for the last 2 meetings that happened since this OpenWorm meeting. Progress, just reporting, obviously, from all the folks that are doing quite good work. There was progress from Dan Crucini on the multiple aspect integration that resulted in, as of last night, in this design proposal that I'm sharing as for how Geppetto could tackle this problem. So I still have to walk through this and basically, I know that Dan has put some questions and proposed some solutions. So, but this is a very good start from something that will enable us merging the part which is about the simulation of the nervous system with the simulation of the mechanical models through cybernetics. So this happened, and it is very, very good. The other meetings that happened were about the instances versus types optimization. All these things are discussed in more details into the Geppetto meeting, but the design card was closed and other cards for implementation were created. We have, just as a general update, 3 new contributors, 2 from the École de Technologie Supérieure in, yes, from, Canada, actually, Quebec.
Well, that's embarrassing for me.
Yeah, so this is the school. They are students of Michael McGuffin that joined us some time ago in the OpenWorm project, and they will be working on a new activity widget that there's a card for, and I linked it down here for at the moment it's a placeholder for the effort. I have the first meeting with them this Saturday. So other than that, I will let Joe say everything about the WormSim stuff. So I don't need to do that. We are in general we've made good progress on the HTF5 library for reading and creating HTF5 recording formats from inside Java. Work on the conversion service that will allow us in few months basically to run neuron-based simulations from starting from a NeurML model and using Geppetto. I won't touch on Sergey and Martin. Joe, you can say about their progress in terms of the simulation loop for the cybernetic and what Martin has done. I touched already on Dan. Kyle is still working on LibRoadrunner, and now we have more intersections given that we're basically enabling Geppetto for running external simulations that he will be able to take advantage of. Yes, and Mihai, a new contributor that is working on WormSim, and again, I will let Joe talk about that. So this just a very brief overview into what happened in this past month. There is a lot of code that is being written, most of which is still inside branches, and it is not merged or exposed through any release. So, and it will probably be another, not this next release, but the one after, where some of this code will actually surface. Yeah, what I wanted to, yeah, I had it ready now. I have to reload it, but I just wanted to show the C302 briefly simulation where there have been some fixes. I think compared to the last meeting when we had it here, and it is basically loading just one of the models that Porig was showing first, that are the output of the C302 Python stuff. Yes, let me do that before I get into this, and I will try to be as clear and as brief as possible. So this is the C302, one of the models that are the output of what Porig was showing. So in this case, the simulation is running using JLAMs. As we know, the green dots are basically neurons that are active, and at the moment only 6 of them are hooked up in the simulation. So we see some of them blinking, and this bit was already working there. We're improving a lot performance in terms of how long it takes to load and run the simulation, so that we have already some good improvements in a branch that will make it into the next release. But in terms of something that I don't think we did see in the context of the OpenWorm meeting is the fact that now we do have connection lines of different color between the neurons to see what is connected to what, and depending on the color, we basically distinguish between what is an input connection, what is an output connection, etc., and it makes it really easy to basically navigate. And if I open the console, you can even see at the moment what is the particular neuron that I'm selecting, and then you can see even when there are, for instance, there is a DAR that is connected a lot, and it's actually really nice to look at it, and you can see the shape of the worm as that goes through from the head to the tail. So this is actually something that we didn't have before, and it is now working. Obviously, the same thing is possible to do with the smaller sub-circuits that Porig was describing. Yes, and all of those. That's why I was asking about making them easily available on the open source brains side of things, so that people can easily get into working at this model, because this is just one of the samples that we have here in Geppetto. And I don't want to, these are meant to be samples, not to be a repository. So that's where all of them should be really coming from.
Matt, I have a question.
Yes, and there's also
question on this is, do we already have a widget that when you click on a neuron can show you the list of inputs and outputs of that neuron, or network in general?
Yes, we do. It's the tree visualizer widget.
It shows you already like the list of inputs and outputs for each.
It does, and we have in a branch that is not yet merged into development the ability for this widget to change its content based on what you click on.
Oh, that's cool.
So that you will be able to see exactly that. And this is something that we didn't have yet, which made it into the latest release. This is Geppetto showing another model, which is the muscle model that is coming from another group, which is the effort that Stephen is driving forward, and we see that the morphologies are displayed. In this case, it's a cylinder and a small sphere, as you can see here. And the simulation is also running. The simulation is particularly slow in this one, and which speaks to the improvements that we're doing in a branch. But actually, you'll see that there are numbers moving as the simulation is running, and you see that the plottings are also getting updated. So this is where this is going, really, is to give a unified, simple way to explore all of these models. And yes, and you can even in this case you can select the muscle cell, for instance, and see through that line that it is connected to the integrating fire neuron that is in this particular neural network. So I think these were these things made it to the latest release of Geppetto that was out in between the last meeting of OpenWorm and this meeting that we had today. So I don't think we did see any of this stuff. But it's nice because it shows that everything is converging, and we are getting to support basically all the models that OpenWorm is spitting out, and which is really where we want it to be. Obviously, it's in development. It's like you see that there are hundreds of cars in the Geppetto waffle board because there's lots of stuff to do. But this is still progressing nicely. Any questions about this before I showed that diagram, which is less about Geppetto but more about OpenWorm as a whole? Okay.
I just want to say that I think it's awesome. So.
Okay. Thank you, Stephen. I hope you are not biased, but yeah, no, I believe so. I also believe so, and I'm probably even more biased. But it's like seeing all these things working after many years at this stage of effort is like rather nice, I have to say.
Yeah, that's good.
So, okay.
Question, should we go on to the integration topic now, or should we let everybody kind of do an update and then come back to it?
Either way works for me.
Just a little...
Yeah, let's finish the update maybe, and yeah.
Yeah, okay.
That might be nicer too, so that I can catch a breath.
Yeah,
okay.
Pause.
Thanks.
Cool. All right, so next on the list is Giovanni.
Okay, so I'll give a brief update on what I've been doing, and one of the things I've been doing is coordinating work on this WormSim project, which is pretty much taking all the stuff we're doing, at least the things that are more consumable by a broader audience, and exposing them through a simple user interface that people can go there and have tutorials to explain what's going on. So before I talk about that, I just wanted to also say what else I've been doing. And in particular, in terms of Geppetto development, I've been kind of working with Matteo and the guys, Adrian and Boris, doing design for some Geppetto features, such as this Geppetto dashboard that's going on, working on database design and web services for that, and then some kind of general design issues in Geppetto and performance optimizations. But so that's pretty much other than the worm sim. For the worm sim, my role has been mainly coordinate the work that's currently going on. I do try to write some code myself and trying to close at least a card a week that has some code in it. But due to limited availability, I can't code too much. But there's loads of stuff going on at the moment, and I'm just going to give a brief update of what that is. At the moment, the WormSim team is Matteo, myself, sometimes Jesus helps us, and Sergey, Martin, and as Matteo said, Mihai, the new guy, starting this week. So in terms of updates, one notable thing that happened, and it's not just WormSim related, is since the WormSim is built on the Geppetto platform, we did, I mean, most of the stuff that happens is kind of at the interface, and there's loads of overlapping tasks. So Jesus recently lent a hand and managed to put together a proof of concept of streaming Geppetto recording from the server to the client, which we are going to need for the WormSim. So thanks to Jesus for that. Then Sergey has been producing an SPH recording. So one of the features of the WormSim is going to be that people are going to be able to access and play with an SPH recording. The reason for it being a recording is that at the moment the particle-based simulation is huge, and we need to pretty much go from a particle-based simulation to a meshes and an animation animation scene, and Sergey is working with Martin on that. While Sergey is producing a recording that can loop, so starting from a given shape of the worm, output from cybernetic, and it's producing basically data that is then getting processed by Martin, who is a 3D expert. And Martin is taking this particle-based shape of the worm and the muscle cell and generating meshes and skeletons and bones and animation matrices that will then compose the Geppetto recording that we're going to stream from the server to the client. And also Martin has been helping writing the JavaScript code that will animate this stuff on the client side. So that's pretty much what's going on, and there was a lot of progress on that recently. There's good collaboration between Sergey and Martin has produced some good stuff. This week we had a meeting. It showed us JavaScript, pretty much a moving worm in the browser, and I'm hoping by the next meeting we can show at least a video of that with some decent data, because at the moment it was using like mocked data. Or not just mock, but it was from a previous recording that Sergey provided that had some issues, and those issues have now been fixed. So we should be in a position that next time we can at least see this animation in the browser of the mesh-based model of the worm. So it's pretty much the same as SPH, but it's not based on particles anymore. It's based on meshes, so that we can send it from the server to the client faster. And what's coming up next, it's basically we need to take all of this stuff and put it together, and Mihai, the new contributor, is going to help on that. And so basically we're going to take the output from Martin's, so this data that is basically meshes and visual transformation matrices and information about skeleton and the animation itself based on the cybernetic simulation. We're going to package it into a Geppetto recording, and we're going to stream this information to the client. We integrate the code in JavaScript on the client side to animate this. The interesting thing about this stuff is that, and I believe, I mean, that's probably relevant for the movement validation stuff, is that a similar solution could be applied to serve the data produced the movement validation through Geppetto, because it's pretty much you package it into a Geppetto recording format, throw it into the browser, and it's gonna be different visual data, but it's gonna be visual transformations. So we can, I think, reuse the same strategy. So when that meeting happens with Matteo and Mike, I'd like to sit in, make sure that we are kind of maximizes reuse of that stuff. And that's pretty much a brief update on all of this. I hope next time to be able to show some more stuff. Right now, I can bring up the current version of the Worm Sim front end, but most of the work is actually going on under the hoods. So there is probably no visible improvement from the point of view of what I'm gonna bring up now that you probably most of us have seen already. Some of us might have not. So I'll just briefly share what we have at the moment. But so this is pretty much a canvas, and some of the things here, I mean, for example, the UI will be reworked and all of that. And most of the work at the moment is happening in the background. So it's, as I said, this is not different from the versions that we presented before. But just to remind everybody what this is, it's a worm sim. You're going to have a tutorial on this page. Clicking on these buttons can change the color of the cuticle. Clicking on these buttons, they will go to the Geppetto environment. And for example, this will open the C302 simulation. This will open the SPH recording. So those two simulations, those two models, the mechanical model and the electrophysiological model, are going to be the first one that we serve. But not my idea. I think we have thrown this idea around before. Is that as we have new kind of accessible models that come available in the form of output from any other sub-projects in the context of OpenWorm, we can add buttons down there, and for example, I don't know, movement validation data, we could serve it through the WormSim, or any other models like that. It would be, I think, this is the perfect window to unify the output of things that are consumable, and sometimes, yeah, I've said before, in an easy way, but this stuff is going to be usable at different levels. So, for example, the C302 stuff, it's cool to look at. There's neurons lighting up. You can see the network and stuff. But if you're actually into that kind of line of work, if you're doing science, you have a deeper meaning of what's going on. You can actually use it to do some investigations. And so, and the same for cybernetic. And then as we add new features to Geppetto, like setting parameters, then it all becomes even more interesting. But so yeah, I think that's everything. I just want to show you what happens if you click on those buttons. The Geppetto instance customized for the WormSim comes up, and right now there's only a placeholder, so this worm will be moving like the cybernetic simulation, but you can see this is a customized front end with a WormSim logo down there. There's a home button up there. This, and again, the layout is not final. Matteo is going to help us with beautification as he usually does. But if you click home, it goes back to the previous page and so forth. And then built into this page, we have a mini worm browser that will show muscles and nerves. This buttons up here will change into some kind of a, yeah, this is too dark, but these buttons up here will change into some kind of a slider, and that's pretty much it. Hopefully more to show next time, and that's all.
Cool. All right. Very good. Love seeing the progress. Anybody have any questions for Joe? Tom, how are we doing? Do you want to? I feel like you had a question, so I just didn't want to like continue like railroading past. If there was something you wanted to ask, but I didn't see you type it in the chat yet. So, okay, all right, we'll just keep going.
Cool.
Okay, great, thank you, Giovanni. All right, so it looks like we don't have Andre today. Poreg, do you have any new topics on beyond the overview that you gave today that you'd like to cover?
Not so much. I did visit Netta Cohen about 2-3 weeks ago and had a chat. She's very pleased we're using her muscle model, and she is still on board with the project, happy to help in various different ways. She is working with somebody in also in Leeds who's looking at who is in I believe computer science, looking at creating some 3D mesh simulations, something along the lines of what Cybernetic does, but using slightly different solvers, different methods. I didn't get too many details. It's not publicly released yet, but I've convinced her that it would be useful to share this once it becomes available, but also because we have a neuronal model that can operate and generate behaviors on different levels, it might be useful to look at the possibility of using something like C302, plugging that into their 3D simulator to try to provide the input into the model, and in the same way that we're planning to plug C302 into Cybernetic. So I've let her know about that, and hopefully have more details of that as it becomes available. I also revived, so the link I put there was for open source brains, Yelligan's neuromechanical gait modulation, and actually I can't show that again, unfortunately, but Stephen, can you follow that link?
Yeah.
So.
Okay.
Okay, so if you go down, yes, Michael, this might be interesting for you. This is their 2012 paper that they've actually produced a model of a moving worm, and this is it's actually C code that they have. They've optimized the model. They can run the simulations to investigate various different viscosities of liquid that the worm model is placed in. So they can simulate water, they can simulate other more viscous mediums, and simulate behavior of the worm and compare that to the real things. So when it's splashing around, when it's in water, when it's crawling on a surface. And this code is available. It works again. It should be relatively easy to compile. So if anybody's interested in that, I wanted to try to have another go at it, just making sure that it's producing correct behavior in different viscosities before announcing this again. But this might be something quite interesting for movement validation people, because it is it basically produces a set of images of the worm at different points in time, which looks quite easy to extract the body shape from that, and it might be a way in to get a pipeline to get some simulated behavior for comparing to real worm behavior.
Cool. Oh, that's interesting. Comparable, yeah. Michael, you might want to show that to guys or something. I don't know. Just maybe check it out. Okay.
Okay. So no other.
Anything else?
No.
Okay. Awesome. Very good, sir. Let's go on to Balash.
All right. Can you hear me now?
Mm-hmm.
Yeah. Okay. All right. So last week I also had a meeting with Andre Brown. I was down in London, and we set up a meeting in his office. We had a good chat, and that had several outcomes. First and foremost, I have some of the videos. That is information for Stephen, because he has the hard drives, but it was difficult to get the movies from it. But basically, right now I have the video, Stephen. So that's check.
Okay, good.
Yeah. And that is important to me because, as some of you know, I'm developing this little side project within movement validation called motif validation, which is my PhD. Basically, in the last months, well, the last 2 weeks since I have the videos, I adopted the framework for the worm. Earlier, I've written a paper which is for Drosophila, but we've decided not to submit it and just wait until we get the worm results as well, but that is in now. And right now, that paper is like about 95% ready to submission. As we speak here, I'm just on my other screen on my desktop computer, I'm recording some movies that shows the annotation that this produces. So that will be a paper that will be out very soon. Well, it will be submitted very soon. We'll see when it comes out. But anyway, that's on the way. I know that for many people, this motif validation has been a bit of a mystery. What is it exactly? But the paper will be out soon that explains it. I'm still looking at the worm results, so it's not sort of like 100% what I'm going to say, but I am getting more and more confused that this whole business of omega turns is a little bit dodgy. And that is interesting because everybody uses that, but again, these are preliminary results, but I'm like 90% sure that there is like really no distinction between omega turns and some of the other turning behaviors. You don't see in any of the features any cutoff where the omega turns begin and the other behavior stops. So I think it is much better to think about it as a continuum between the different behavioral states. Again, this is not 100% yet, but sort of everything that I'm looking at right now is pointing at that direction, but there are still a few background checks that I want to do. So mostly I've been just busy with that, and other than that, what is directly related to OpenWorm, I was just working a little bit on the government draft. I posted some comments there and put it together, some paragraphs for the mission statements and such. But what I also wanted to raise here is that I will want to upload my code for this motif validation to GitHub. And it is a MATLAB code, which is unfortunate because it's not Python. It's not something that could be run by anybody. But I would like to upload it to the OpenWorm GitHub. I hope that we will use some of these technologies later in the movement validation as well. But at this point, it is not strictly included in what is OpenWorm going to use. So I just wanted to check if everybody is okay if I upload it to the OpenWorm GitHub page.
You mean in the movement validation repository?
Well, I mean, already in OpenWorm, we can just have like a sub repo for this.
If it stands on its own as a sub repo, then I certainly say it's fine. If you wanted to put it in the movement validation repo, that's also fine. I would say multi-language is fine. That might even encourage someone. We throw up an issue saying, does someone want to translate this, depending on its complexity. There's a tools folder in the movement validation repo where standalone pieces of code can go to do little things.
I was thinking more of like a standalone depot because it is.
Sure.
It is a standalone software package, and I expect that many people from the Drosophila community will use it as well. But
cool. Okay.
As far as translating it, it is pretty complex. Like I'm not a big computer expert. Oh yeah, hi Alex. Hey. Yeah. So I think that would be a lot of work for somebody to translate it. But if anybody is up for it, then hey, it would be just that much better.
Sounds good.
Yeah.
Alrighty. Very good. I want to say anything else about like WormSim tutorial text or?
No, that's sort of already finished, and yeah, it's already in the doc. I think Giovanni integrated it with the master document, so sort of like.
Yeah, I linked it in, but I do want to talk to you about it, and it's overdue. So I think after this one, let's organize a chat.
Okay, yeah.
Because I read it. I think we need to talk about it. It looks great. I just wanted to thank you for doing that. And yeah, we just need to make it into...
Yeah, sure. Okay, yeah, let's chat after this. Yeah.
All right, cool. Good stuff. So Tom, do you want to give an update via chat that we can just read? I can't hear you, unfortunately. Okay, revised neurocomputing paper, second time. Hope it flies this time. Getting an unrelated paper results collected. Comparison of artificial neural networks playing Pong. Cool. Keeping on keeping up on great work here, and expect to get more online in a few weeks. Okay, cool, very cool. Yeah, and if there's anything as well, since you were teaching recently, if there's something in your world that you'd want to put up as a Google Summer of Code project as well, I don't know what your summer bandwidth is like, but just a thought that there might be something cool there in your space. So please, again, feel welcome to do that. The pattern is there that I linked up online. Wow, so we have 5 minutes. I really wanted to get Matteo to talk about the diagram. I also just want to let you know that a lot of things are going on under my wheelhouse that are sort of not organizational stuff, but just sort of under individual projects. So I think we're not going to have time to do the diagram this time. Matteo, can we do it next time? Can we carve a space out for doing it next time?
Yeah, sure.
Okay. All right. So then just real quick on my side, some things. So the lab of Ed Boyden at MIT released a new technique called expansion microscopy. There was a write-up about it. Actually, he likes to point to the OpenWorm project as a potential consumer of this expansion microscopy technology. Basically, the idea is instead of making your microscopes better and better at seeing smaller and smaller stuff, that you actually use a gel to make your sample larger. So you actually literally inflate the sample and make it bigger, and then you can see more details there. So it's kind of interesting. It actually works. Anyway, he's been investing more in C. elegans. So he's got a grad student now that comes from a C. elegans lab, and he's actually been reaching out to us to connect him with folks that have expertise on how to do experiments that cut through the cuticle of the worm, which is a tricky thing for getting chemicals inside the worm, as the cuticle is rather tough and hard to break down. So we've actually connected him with the Emmons lab, which you remember is Steve Cook, who was helping us out, comes from there, and him and Scott Emmons and David Hall are having a very nice conversation back and forth, and it looks like we may benefit from that at the end if they can get some good data that comes out. So this is one of the ways in which we're working with biologists. We're putting folks together. Emmons is in New York, in Einstein, the Einstein Institute that's there, and Boyden is at MIT. So we're fostering collaboration, which is cool, and we'll see where it goes from there. So we're hoping that cool data sets come out of Ed Boyden's lab, and that he wants to donate them to us, and at the same time showing off his cool new techniques. DevoWorm, I don't get to update you guys very much on this because it is more about modeling development. It does sometimes stay a little bit on the sidelines, but I do have an update for you on that. First of all, these are the folks that are involved in it. I just wanted to point out that this app that's called Worm Guides, which is essentially it's an iPhone app where you can browse all the cell divisions through a few stages of C. elegans development. You can see a picture here. So each one of these is an individual cell, and it goes through time. So we've actually had the data set donated to the project by Zhirong Bao, who's responsible for that. So I have it, but we're just working out what the license is so that we can share it with the community. We just want to make sure that everybody in that group agrees that I've got it, but I don't want to distribute it until everyone's clear on the open license. So we're just working on establishing that, but that should be available for folks as well. And because it's a nice data set, we can imagine visualizing it in Geppetto, we can imagine visualizing it in other things, and then also building models that actually move that forward. So there's been some conversations with the group at CompuCell 3D, actually, CompuCell 3D, which does do modeling of development. But this is still also very nascent, but nonetheless, it's a little bit of definitive progress, at least, that we've got a data set now that we could put up on GitHub once we get the license.
I imagine like something like the worm sim, where we could show that death before there is the full model that moves. That would be cool.
Yeah, exactly. Like have this up on the web, and I think they're also interested in, in ways to do visualizations, because that's, that they did put this app up, which is cool, but it's not necessarily their strong suit that they want to be investing in. So, so anyway, so that's just an update there. OpenWorms, we talked about it today. So Mark Watts is still involved. Travis Jacobs has been contributing. They've been doing good stuff. This waffle board here shows you where we are. We've gotten through quite a bit. We're working quite a lot on this pull request here. So if you go to this pull request 95, you'll get a lot more details on where we are. Basically, we're trying to make sure that we pass all the unit tests before we push. So some of the sort of boring stuff, but our unit tests are kind of in a state right now. I mean, the tests are fine, but we're not passing all of them, and we're not exactly sure why. And so anyway, we're going back and forth on that. But these are kind of the this is filtered to the last issues before we push to master. I know I've been saying that now for months, but we are making steady progress. It's just it's just sort of slow going. So you can have a look there. What's going on with that as well? Muscle neuron team. So these are the folks there. We had a meeting this month, which is up on YouTube. Here's the agenda for it. We also did a journal club as well, talking about synaptic junction and some of the points that came out of the agenda I don't have time really to talk about, but you can feel free to click on this. A gentleman named Vahid Gayumi is really stepping up and doing organizational planning. Our GSOC idea is sort of deriving from integrating, the directions that we've had and his directions. One thing that's cool just to show here is that we've identified a good open source tool for digitizing some of the plots from some of the cellular data that come out of different figures. So this is just an example, but this open source tool here lets anybody on the web take a raster image. You might clip it out of a paper and turn it into a digitized image, and then submit it to something called Plotly that lets you view the data and have it exported in JSON, exported in all sorts of nice formats as well. So this is part of the pipeline that Vahid and others have been describing to basically be able to have targets for current voltage plots for cells and for muscle cells, and also eventually the neurons. So that's been very cool. There's also I've been updating. Oh, that's not the one. No, this is the one. I've been updating the docs on OpenWorm. For some reason, this is the wrong URL. But I've been placing the meetings and the agenda up on this project, Muscle Cell Integration. I've also put down I've updated some of the key issues in the roadmap for the muscle team. And then I've added some background materials, which are actually rather nice, that came up in this last month. Some 2-minute YouTube videos introducing basic concepts that are relevant to the project are also up there. So, and this is up on the web for folks to see. So that's another thing that's cool. It's been happening. Lastly, let's see, is it over here? No, it's not. So right, this data server in the last month, I managed to get it up. I had to, the OS was broken on it when I got it, this box of hard drives. And I sort of shown in terms of screenshots how it was broken. And but I managed to finally, I think since the last meeting, reassemble the RAID array using an Ubuntu USB stick that I had to plug into this thing. And I've been going back and forth a little bit with Balazs to get specific videos out. Now that I know that he's got the videos that he needs, I'm going to go back to putting this thing up so that it's accessible via torrent, which has been my original goal. But you can follow the progress on that issue there. And 3 minutes over. I have had an idea, which I'm not going to go into now, but maybe of having a hackathon where we actually somehow, across multiple time zones, coordinate some synchronous time for doing programming. And it probably couldn't be, super continual. So maybe even just like a 4-hour block that multiple people could attend at the same time would be something could be pretty interesting. Just again in the spirit of integrating. How to do it separated virtually is a bit of a challenge, but some tools like Screen Hero are now starting to offer group screen sharing, or using Gitter as a way to do it, or also just being present on a Hangout simultaneously for like 4 hours or something. is an idea that's bubbling around. So think about it in the back of your mind. Don't have time to go into it now, but I think it could, as this project is scaling, I think it could be a helpful way to do it, and we could also just try a new model of a virtual hackathon that hasn't been seen before. So always looking for new ways to integrate. If you guys have ideas as well, please send them to me. Okay. Anyone want to say any last words here before we close up? Okay. I would just plug, just try and have a look at this diagram that Matteo put together. I'm sorry that we ran out of time. We did a lot of good updates from folks. I'd like to hopefully start with that next time, and because it does start to put these pieces together. As well, this Gantt chart that I'm putting together will probably be more fully fleshed out by then.
And thinking to strap it to a GitHub issue on OpenWorm as something to give the opportunity to everyone to put a comment on it, because it's possible through Lucidchart, but everyone has a GitHub account, and not everyone wants to bother with Lucidchart. So that might be a way to just have people looking at it and commenting.
That's terrific. All right. Thank you, everybody. We'll meet again in 4 weeks. It's on the calendar. So we'll till next time.
Thank you.
Cool. Thanks, everyone.
Bye, guys.
Bye-bye.
Have a good day.
Thanks. Thank you.